Hi, I am R. Venkatesh, Assistant Professor in Department of Electronics and Communication Engineering at Rohini College of Engineering Technology, Anjigramam, Kanyakumari district. Now I am going to present a topic in optical communication, the title Attenuation and its effect in optical signal. After the completion of this topic, student will be able to explain about the basic concept of attenuation effects in optical fiber. Introduction. Attenuation. In optical fiber, the signal transmitting through the fiber is degraded by two mechanisms. So one is attenuation and another one is dispersion mechanism. Both of these mechanisms are important to determine the transmission characteristics of the fiber at operating wavelength. So attenuation is referred or dispersion is referred is the transmission or signal or fiber loss of optical fiber are proved to be one of the most important factor in telecommunication system. So when a signal is attenuated, then there will be a fiber signal loss. What is meant by attenuation? Attenuation means referred as power loss in a fiber cable is properly the most important characteristics of the cable. This power loss is often called as attenuation. So it determines the transmission characteristics of the fiber. Attenuation of a light signal as it propagates along a fiber is an important consideration in the design of an optical communication system. So when a signal is attenuation, then the maximum unamplified signal and the maximum transmission distance between the transmitter and receiver can be measured with the help of the attenuation. So for these reasons we are going to find the transmission characteristics of the fiber. Due to signal distortion, the pulse will be broadened, and as they travel along the fiber when it is propagated inside the fiber channel, then it will be overlap with the neighboring pulses and it create error in the receiver output. So it play an important role in determining the maximum transmission distance between the transmitter and a receiver. Attenuation is a measure of decay of signal strength or loss of light power that occur as light pulse propagate through the length of the fiber. Otherwise, if it is referred as, it is defined as the ratio of input transmitted optical power Pi into a fiber to the output received optical power P naught from the fiber. So attenuation has several effect on the performance of the fiber, including reducing the system bandwidth, information transmission rate, efficiency, and overall system capacity. So, signal attenuation within the optical fiber is usually expressed in the logarithmic unit of decibel. The decibel, which is used for comparing two power level, may be defined for particular optical wavelength as the ratio of the input transmitted optical power Pi into the fiber to the output received optical power P naught of the fiber. So the standard formula for expressing the total power loss in an optical fiber, alpha dB is equal to 10 log to the base 10 Pi divided by P naught. So, in optical fiber communication, the attenuation is usually expressed in decibels per unit length, that is dB per kilometer. The basic source of attenuation mechanism in an optical fiber or signal degradation factor of optical fiber is given as absorption loss, scattering loss, bending loss, core and cladding loss, and radiative loss of an optical energy. So, in an optical fiber, the attenuation is considering the propagation distance. It is usually expressed in decibel per unit length. So the absorption is related to fiber material and scattering are due to fiber material and which structural imperfection in the optical waveguide. Radiative losses occur whenever an optical fiber undergo a bend or micros bend. So bend means both microscopic and macroscopic variation in the finite radius of an curvature. The attenuation unit as a length a light traveled along the length of a fiber, its power decreases exponentially with the distance. The power at the distance Z is given by P of naught into e power minus alpha into Z. So the alpha is the fiber attenuation constant per kilometer and the attenuation coefficient alpha in the unit of decibel per kilometer is given as 4.343 into alpha per kilometer. Thank you.